Hey everybody, in this video we are on the third example of section 3, properties of logarithms in the unit exponential and logarithmic functions. We are going to be getting into the power property, which stems from the property of exponent rule that you see, b to the m raised to as a quantity n, and in that situation we know we should be multiplying our exponents, so it equals b to the m times n. So there's like this multiplication step involved when raising something to a power. So in the power property, what does that look like? Well, log base b of m to some n power will equal n out front being multiplied by log base b of m. So in this situation, the power can go out front so long as the thing that you have is just one thing raised to a power. We got to be pretty careful when we're dealing with products and quotients inside of the log as well, and we got to make sure we separate things correctly. So we're going to see a few very simple examples before we get into examples 4, 5, and 6, which are a little bit more elaborate. So let's get into it. Here we go. We have example 3 using the power property. So let's get into, did I say power before? Or did I accidentally say product? Because I meant to say power for sure, and now I don't know what I said. Hopefully I said the right thing. Okay, so let's go. First example here, we have log base 5 of 7 to the 4. So all we do is we bring the power out front. Do I have to write this dot? No, I don't have to. I'm just writing it now to really highlight that it's being multiplied. 4 times log base 5 of 7, and that's it. You are done. How about our next example? Well, before we do anything, I'm going to rewrite it as ln of x to the 1/2 power. It's important that you know that the square root is the same as the 1/2 power. More specifically, the radical, I'm going to put a p as this is called your index. The thing inside of the hook of the radical is called your index. And I'm putting a little p there of some x to a q power will be equal to x to the q over p power. So that is an exponent. It's a little poorly written, but that's q over p. And I used to remember this in school when I would say to myself that the queen lives in the castle, she's upper class, and the peasant lives outside in the gutter. Sorry, peasant, they're lower class, like in medieval times. So when you're dealing with the square root, you have a 1 power on the x, and you have a 2 invisible index for a square root, and that's why it's the same as the 1/2 power, okay? Anyhow, now that I've written it with the power, I'm going to, in the next step, bring it out front. Now that I have it as a power, 1/2 ln of x. And that's it. We are done. Now, if that was ln of e, don't forget that ln of e, or natural log of e, is 1. All right? But next example. Now, in this case, this entire quantity is raised to the 5th power. That's important. So the 5 can come out front. We could do this in a couple of ways, and we'll end up at the same answer, okay? 5 out front times the log of the quantity for x. Now, I have a product property opportunity here. So I could take this further. 5 log of 4, and that 5 goes with both, plus 5 log of x. So it's important to point out that this is very different, so not the same. So this is like my not the same. So it's my like no symbol, you know. It's not the same as something like log of 4x to the 5th. In this situation, the 4 is not raised to the 5th, just the x. So when all is said and done, you'll end up with log of 4, or, you know, that could be 2 squared. You can write 2 out front, so we could do more with it. X to the, oh, what am I writing? Distracted. Plus 5 log x. When all is said and done, it'll look like that, because that 5 is only on the x. So hopefully you see that this is not the same as the example above it, okay? So if you got to rewind, watch that part again, by all means, go ahead and do that. But let's get into the next example over here. So we have log base 6 of 3 to the 9. That is going to be 9 times log base 6 of 3. And even though we have a lot of numbers in common with the 9, 6, and 3, there really isn't much we can do to simplify this. We don't really know 6 to what power is 3. So, that is what it is. Next, we have a cube root, and a cube root is quite similar to a square root, except instead of it being a 1/2 power, that one is going to be 1/3 power. So this is the same as the ln of x to the 1/3 power. So that means it's sorry, a little squished down here. Oh dear, too squished. Can I move a bit? 1/3 times the ln of x. All Dunzeroni right there. And last but not least, be careful with this plus sign. Do not get that addition mixed up with anything to do with the product property. All right, don't get that all twisted. But we have 2 out front being multiplied times the log of x plus 4. And I cannot do anything with that x plus 4. That is an entire argument. The adding in there is not the same as the adding you get after you expand a product, okay? So if you need to look at this example and compare it to the video, for example, 1 in this section where we're doing product property, by all means, go ahead and do that. But that's the end of this video. Hopefully you are a little bit cleared up on the power property. If so, thumbs up. And then if not, thumbs down. Questions, comments, concerns, feedback, and requests can go into a comment section. Check the playlist on the screen right now if interested in more content on this topic, or check the description box. And bye for now. Adios.